Good afternoon, ladies and gentlemen. My name is Elaine Azu, and I'm a research scientist from Ghana, specifically from it's a long name, Biotechnology and Nuclear Agriculture Research Institute, but we call it BNARI for short. So I'm going to give an overview of the current research activities that we are conducting at BNARI, and also the ones we are doing on emerging technologies. Okay, so BNARI in itself is not an autonomous organization. BNARI is one of the institutes of Ghana Atomic Energy Commission. In Ghana Atomic Energy Commission, there are 7 institutes. We are there to promote the useful or the application, the peaceful application or utilization of nuclear energy. A lot of the times when people ask me what we do there, we are associated with bombs and whatnot because of atomic bombs, because of the name. But what we do there is actually to promote peaceful applications of nuclear science and related technologies. So we are into nuclear power. We are considering nuclear power for Ghana, and also we are doing some research, medical research, using X-rays and gamma rays, for instance, in cancer treatment. But for BNARI, being one of the institutes of Ghana Atomic Energy Commission, we are into the agriculture part of atomic energy. And there we, like I said before, we are promoting the useful application of atomic energy in agri. BNARI itself also has 7 centers, but I am a plant breeder by training, and I'm at the Biotechnology Center. That's the one at the bottom. But there's also a plant disease research center. There's also a radiation entomology and pest management center. And all these centers work together in BNARI just to promote or provide sustainable solutions for agriculture. Because we are into nuclear techniques, one of our main activities is to promote mutation breeding. And by mutation breeding, I mean we use gamma rays or X-rays. For instance, to explain it more simply, if, let's say, there's a cassava variety that's in Ghana, that is a farmer-preferred variety, and all the farmers love it, but let's say it is susceptible to a particular disease, what we will do is to look for that variety and subject certain parts of the plant, let's say the nodal cuttings or leaves or whatever, any part of the plant that can be regenerated, to X-rays or nuclear energy, in the hope that the DNA of the plant will be mutated to produce useful variation. Okay, so, okay, it's back. Yes, so currently we are using X-rays and gamma rays to introduce genetic variation, for example, for cassava. In cassava, we are looking for ACMV resistance and CBSD resistance. ACMV is a very devastating disease in Africa. It affects a lot of our plants, and our farmers really complain about it. When it comes to CBSD has not been reported in West Africa. We hope that is not the case, but it's usually in Eastern and Southern Africa. But we are trying to find the resistance to CBSD in farmer-preferred cassava varieties that are in West Africa, so that if we hope it doesn't happen, but we should be prepared if CBSD happens to reach West Africa. We also work on soybean, sweet potato, taro, and sorghum and groundnut also. One of the other things we do is also to develop efficient in vitro generation protocols. We have quite a functional tissue culture lab, and it's been in existence for about 20 years. And I know tissue culture is the basis for all these emerging technologies. For instance, you cannot bypass tissue culture when you are doing gene editing in plants or genetic modification, even sometimes in mutagenesis. So we try to establish these in vitro protocols for several crops. So we work with the Cocoa Research Institute in Ghana. We work on cola. We work on shea, the one that produces shea butter. We also work on ornamentals. You know, ornamentals in Ghana is becoming, I think I'm fidgeting with this thing, I'm not sure. Please pardon me. We also work with a lot of ornamentals. In Ghana, ornamentals are really evolving, so we have gotten into that space. We work on some medicinal plants, sugarcane and pineapple. One of the main reasons why we do tissue culture also is to supply disease-free planting material for our farmers. So this is one thing that we are heavily involved in. For instance, we supply a lot of banana and plantain planting material for our farmers. So even though I don't work in the entomology side, I thought I'll just mention a few things that we are doing at the entomology side. We use a technique called sterile insect techniques. It's been in existence for a while, for decades. But what we do is to irradiate the mosquitoes with gamma irradiation and try to generate a population of sterile male mosquitoes, so that when they mate with the female mosquitoes, the wild ones, they don't produce any progeny. The idea is to bring down or suppress the population control or control the numbers of malaria producing mosquitoes in our system. There's also research with black soldier fly, fall armyworm, and fruit fly. But when it comes to the emerging technologies in BNARI, we just ventured into the, genome editing in rice. It doesn't seem clear on the board, but this has been in existence for a bit, even though BNARI just went into it. We are looking at several qualities like disease resistance. We are looking at grain yield, also herbicide tolerance, improved quality. For instance, we can genome edit cassava for the fragrance, also for beta carotene, and even to increase the oleic acid. So there are several traits that can be looked at when you are engineering or we are doing genome editing for rice. But at BNARI, we are focusing on the rice, pardon me, yes, we are focusing on rice yellow mottle virus. This is a very devastating virus. It can cause 100% loss in the field, so that the farmers lose everything. And it's really important that scientists begin to work on resistance for the yellow mottle virus. And we are trying to engineer it in the Jasmine 85 rice, which is a very preferred rice variety that a lot of the farmers in Ghana grow. And also looking for increased yield and drought tolerance. I'm sure most of you understand the importance of rice in West Africa or in Africa in general. And rice is a very, it's a staple crop, or it's a source of nutrient for a lot of our people. And we need to improve the yields, especially in the face of climate change. The diagram on the right is, essentially, I was trying to compare conventional breeding with genetic engineering and genome editing, where in conventional breeding, what we usually do is to cross a male and we cross one variety. For instance, let's say you are looking for disease tolerance, okay? So what we do will be to cross a farmer preferred variety that, for instance, has a high yield but is susceptible to a disease. So we'll find the disease tolerance in another variety that probably is not farmer preferred. So when we cross them, you can get a new variety that has disease resistance, but at the same time is farmer preferred. But the problem with conventional breeding is, even as humans, when our parents make us as sometimes you like your nose, sometimes you like the height that your father gives you, but you don't like another side of what you've inherited from your parents. So it happens the same way with plants. When you cross them, you will get the gene that you are looking for or the resistance that you are looking for, but you will also get other traits you are not really interested in. So that's when genetic modification came into the picture, where now we look for the gene from from a source, then insert it into a new or the variety, so that you don't come with all the unwanted or undesirable genes. Then now we are genome editing, where you don't necessarily insert a foreign material, but you just look for the gene of susceptibility and just break it apart, such that when the rice or when the variety comes into contact with the virus cannot recognize the gene for susceptibility. The next project that we are on is in yam. I think we are in the yam headquarters of the world. Nigeria is the largest producer of yam in the world. Nigeria produces about 65% of yam in the world. Actually, about 97% of the yam that is in the world is produced in West Africa. It's called the West African Belt, the West African Yam Belt. So it's Ghana, Ivory Coast, Nigeria, Cote d'Ivoire, and I think Senegal also, I'm not so sure. But what we are doing also is to use the CRISPR or the gene editing tool to engineer yam mosaic resistance virus. Okay, so what we'll do is to we chose a West African preferred yam variety called Amola. I think Amola is a Dioscorea rotunda. It's a white yam, one of the preferred types of yam that West Africans like. In Ghana, we call it Puna, but it's white, it's sweeter, and it has a lot of market value. But one of the problems of this type of yam is that when it's grown in the field or in the farmer's fields, it is highly susceptible to the yam mosaic virus, which causes a lot of damage to the yam and reduces the yield. So what we are trying to do at BNARI is to use the CRISPR-Cas9 genome editing system to engineer the resistance to the yam mosaic virus. We're asked to talk about science communication in our institutes. When it comes to BNARI, most of the communication in science is left up to the researcher. It's assumed that you do your work, so you should know what to say about your work. Even though we have a communication team, it's sometimes difficult to work with them because they are not scientists or technical people in general. But we try to collaborate, for them to, relay the information in a better way or in a simpler form. But what are the means through which we communicate? Usually we use research articles. I think most scientists are used to publishing in journals, but sometimes we also have presentations or a public lecture or a newsletter, or sometimes there are roundtable discussions. And recently we're beginning to go into social media platforms. The one in the corner, for instance, tomorrow we have a malaria awareness campaign, and we post on our Twitter handle and try to educate the public on what we are doing as scientists when it comes to malaria control. And we also have a quarterly, like a newsletter that sometimes goes around with a basic information about the kind of research that we are doing. So this is how we communicate mainly in BNARI. But the challenge is most of the time as scientists, on my side or the side of my colleagues, we find it difficult to communicate science in a simple or a clear manner. And sometimes there's a barrier of local language. I think today Prof. Ogoyi was asking, how do you say DNA in your local language? And I don't know if it would be a long phrase. It would be very difficult to explain DNA, but these are some of the challenges or the barriers that we have when we are communicating science. And another thing is, especially when it comes to emerging technologies, there's already a lot of existing misinformation. So it's as if you're coming from negative, not even ground zero. You now come to convince them that, or try to change their minds about what they already know, which most of the time is not the right information. So we have a problem with trying to change the minds of people when it comes to misinformation. And the last point is, usually there's a lack of trust in scientists in general. Sometimes even after the technique is explained to the public, people, even when they don't understand, most of the time they make their decisions based on their values or their beliefs, not necessarily on the scientific fact. And of course, like everything else in life, limited funding is an issue because all these things, even communicating science, also costs money. So from our side, we are recommending that science should be more transparent. We as scientists, we think we should be more honest in stating our information, and we should also mention the limitations of our research. And science is also evolving. I think a few minutes ago, one of the questions or one of the comments was that, I've forgotten how it was framed, but the idea is that one thing can be true today and not necessarily true tomorrow in science. Unless it has been established as a fact, science keeps evolving. So we need to go back and give periodic updates on our research so that we will build more trust and credibility with the public. And we also need some increased public engagement, knowing our audience and choosing the appropriate language, and also simplifying the work that we do. And the last point I'll make is that we have to leverage social media platforms. Most of the time, scientists are introverts, or they like to keep to themselves or stay in the laboratories, but it's time to go out there and tell people our story. And the challenge I find with social media is that you can put science on social media, but it's competing with entertainment, with movies, with everything else. So it's difficult to get the attention of a wider audience when you put science on social media. But probably what we can do is to make it interesting or tell it in a story form so that it can attract a wider audience. So thank you very much for your attention, and this is my presentation.